Hello and welcome back for another tutorial. This time you'll learn how to change shape animation based on proximity to the collision object. You'll see how to convert animated shape to solid body and collide solid body with static object by using the physics. In the end, I will show you how to apply collision object and sources to FumeFX directly from the NodeWorks and how to set up rendering with our Node renderer. Now for start, I'm going to create the NodeWorks and I'm going to create one particle that will be our hero bed animation. So I'm going to use the simple gen node with just one particle that's going to be emitted on the first frame. I'm going to increase the speed to 120 and it's going to go into the positive y-axis. Now that's where our hero animation will be, and now I'm going to assign particle shape, and as you can see we have two animated beds here. Each bed shape has its own animation, so I'm going to pick the first one and the second one. Now when you have separated animations between shapes, you'll need to check the join animation option, which will then treat both meshes and one mesh with different animations. So for the fly we're going to add animation, and it goes from frame 1 to frame 21, and we're going to leave cache once enabled, which means that right now this animation is cached and whatever you do with the original object is going to remain cached. That's for the speed. I'm going to add evade, and it goes from frame 1 to frame 17. And for this one I'm going to create something like 4 simulation substeps, and as you can see now our hero bed is going backwards, so we're going to correct this with a spin node. We're going to turn it about 180 degrees on the z-axis. Now you can notice that animation still doesn't play, and for that we need to assign the shape animation node. This node, as you can see, is applied when the particle is created and is going to switch animation playback right away. So I will set animation speed to 2, so the bed moves the wings twice as fast as the initial animation. Now we're going to add another tab, going to call it ball hit, and I'm going to rename this group to the bed, and we're going to get this bed particle group, and we're going to get the object test node, and we're going to test the bed particle distance from the collide cylinder node. Changes to the surface distance, and now what I wanted to do is when the bed approaches this pole, it detects proximity and is going to change the fly animation to the evade animation. So it kind of looks, it spotted the obstacle and it's trying to slow down the path. So the distance, we're going to use compare, and let's say we're going to use 66 distance units distance from the object, and in this case I'm going to change the animation to evade. Now we can see it's the play, and the sequence is evade. Okay, now we see the bed flying normally, and when it approaches within the distance of 66 units from this obstacle, the fly pattern is going to change to the evade mode. And let's increase the playback speed to 2.6, and of course we'll have to add some drag, as the bed is going to slow down a little bit before the impact as the result of the evade maneuver. As you can see now, the fly animation transition very smoothly into the evade animation, and this is just by a pure coincidence, but in most cases this won't be like that. So we'll want to enable the smooth transition, which will enable the system to create smooth transition between two animated meshes for the duration of 6 frames. In this case, this is something that you probably should use in most animation setups. There's going to be another switch based on the distance that's going to convert our bed into a soft body. So that's going to be something that's really close to the pole, and in that case we're going to switch this bed into soft body so we can perform collision. So let's use cloth and soft body, and for the NodeWorks I'm going to hide. You see, all those vertices are converted to particles that are within the cloth particle group. If I change the color here, we'll see our particles, so I can hide it. But now, since we have this cloth and soft body, switch to the solid soft body, because we're going to need to use soft body solid fibers. Those fibers are created inside an object. They fill interior of the object. It gives it volume and the firmness. So those soft fibers, as you can see, are dominant within the bed volume, and there are not many fibers on the wings. So the wings will be supported by the bend constraints that will prevent those wings from bending too much. I'll use the strength for both type of fibers of 10, so we can see different type of fibers, bend fibers on the surface, as well as stretch and shear. And now we have to add collision handling with the PhysX. Let's first create the PhysX solver, as other PhysX nodes are going to use it. So I'm going to add static objects that don't move throughout the simulation, that aren't affected, and for this purpose I'm using the PhysX static collision, and I'm going to pick the cylinder object and the ground plane. I need to reduce the bounce to 0.3, as the muscles and tissue doesn't bounce a lot, and increase the friction. So using the sim group 0 for bed, and it will collide with group 1, which is going to be cloth particles. Second collision pair are going to be our cloth particles, and I'm going to import them as PhysX object. It's going to be sim group 1, and it's going to collide with group 0, which is the cylinder and the ground plane, using the sphere, radius 0.2, reduce the bounce to 0.3. We want to keep a little bit of bounce, and dynamic friction again to 3, and don't forget to lock the rotation, as we don't want those particles to rotate on the collision with objects, we can increase this position and velocity iteration for more precise solving. Now we can play this animation, and as bed comes close, it's going to collide. However, as you can see, this is not the best position for the collision. I want the bed to have the wings spreaded, so I'm going to change the animation offset and adjust this accordingly. Let's turn this display to the dot, so we know at which frame is being converted into the solid body, and we want this to happen not on this frame. So let's change this distance to something less, for example 8 or maybe 10. And now if we grab the time slider, we can see that our bed collides with the cylinder. Actually, the cloth particles are colliding with the cylinder, and we can change this back to small points so we can better see the mesh itself, and you can see how it stretches a lot. So this is usually something that can be solved with increasing number of the simulation substeps. So I'm going to increase the simulation substeps to 4. And for the fibers, I'll use something like 70 sub-iterations, which will be enough. Since the cloth particles are now included into the physics simulation, we'll want them to be affected by the gravity. So we need to get the cloth particles and assign gravity into the negative z-axis direction. So after the collision, particles and our bed are going to slide downwards the cylinder and hit the collision ground plane. As you can see now, this bed is a little bit too soft, so we have to do some adjustment. I'm going to decrease the mass for this entire object. It's divided among particles equally. I'm going to increase the number of fiber iterations to 100, and I'm going to increase simulation steps to 5. However, I'm going to increase the stretch fiber strength to 10 and the stiffness for the solid body fibers to 30. For the ray direction, I'm going to spread those internal fibers for 35 degrees, and is going to provide a little bit more support for the entire body, so you can see it behaves a little bit better. Okay, so now we'll add some FumeFX. Let's create FilmFX tab, and now we can record all the collision physics results, and pair A is ID 0, that's the pole and the ground, and pair B is 1, that's our bed particles. And I'm going to create one custom channel here, create custom channel, and I'm going to rename it to collide, and it's going to be of the integer type. We don't need float, so it's going to be an integer type, and it's actually going to be the counter of how many times the cloth particle has collided with the cylinder and the ground plane. So for the pair B, which is a cloth particle, we're getting the collide custom channel value, and we add 1 to it. So each time it collides, its counter is increased by 1, and we need to put this value back to the collide custom channel. And for this set particle attribute, is going to be added only if the collision pair has been found. So now when the setup is done, there's one thing left to do, is to export all this data to caches, and don't forget to enable custom channels export, as we're going to need them. I'm going to use the user-defined simulation range from the frame 0 to frame 150. Now once the caching is done, I'm going to create another workspace where we're going to load our caches and play with the FumeFX. Navigate to the path and frame to 150 and create missing group and missing channels. We definitely need it to load the custom channel. And here's what we've computed. Now everything is cached, as you can see. So now I'm going to show you, here's the FilmFX Grid. So as you can see, the FilmFX Grid is created around this cylinder obstacle, and it's a bit bigger than the bed itself, so it doesn't block the smoke and fire. So for the parameter check, we can see what's different within the grid from default, and we are going to simulate from frame 70 to frame 150. And for the ignition temperature, I have set 0, so it always burn, and the burn rate is set to 20, which means it's going to be a little bit longer burn, but we won't see long flames either. For the longer frames, burn rate should be something like 5 or 10, and using expansion 2 to give a little bit more volume to fire and smoke, and fire is going to create smoke as it burns. And now we're going to compose the FumeFX simulation sources and collisions from the NodeWorks. So first we need FumeFX simulation reference, which we're going to pick the FumeFX Grid, and this node is going to provide FumeFX interface to other FumeFX related node from inside the NodeWorks. Now I'm going to import the collision objects first. That's called the Grid Obstacles node, and we're going to pick the cylinder and the ground plane. So smoke and fire are going to collide with those two objects. And of course using the FumeFX simulation ref node as the interface with FumeFX. Now I'm going to enable the create missing groups, so we have in this workspace same groups as we had in the workspace 1. So with the get group node, I'm going to retrieve cloth particles and their collide custom attribute. As you remember, this collide attribute contains information about cloth particles that have collided with the cylinder or the ground plane, and this value is greater than 0 for those particles that did. And I'm going to use the grid sources that will emit only from those particles that have collided. I'm going to emit in the radius of, let's say, 1, and I'm going just to emit fire. I set a small temperature because I don't want smoke to rise a lot, and we can do that and still have the burn because I've set the ignition temperature to 0 here, so whatever is above 0 is going to burn. So this means cloth particles that have collided are going to enable grid sources to burn. So we can hit the simulation. Now you can see that on collision fire emission is going to happen only on those particles that have collided with this pole, which means those particles are going to emit all the time. However, that's one way to do it, but I want this bed to be completely engulfed in flames on the collision, so not going actually to use this collide, and going to do particle group will be here, but going to control emission in a little bit different way. So I want this bed, when it collides completely, so that's frame 83, to ignite, for example, in frame 95. So we need simulation info and compare if the frame is greater or equal to the 83 and the frame is less than 95. We add the logic. Both condition has to be satisfied, and in this case fire emission is going to be enabled. However, I want also to have smoke to continue emission from the bed after the ignition is done. So after the ignition ends on the frame that's above or equal 95. However, I want the smoke emission to gradually fade. So from this frame I'm going to use remap, and it's going to go from frame 95 to 110, and I want to have emission of 1 at frame 95 and 0 smoke emission at frame 110. So this is going to be a smoke value, and at any time you can check the value with display pin value node. Now see it's 1, and it gradually falls down, so the emission is going to end smoke when the bed is lying down on the floor still. So there's the setup here. Now let's start the simulation, and after the simulation is done, let's set up the rendering. So open up the Arnold render view, start the render view, and I'm going to show you how this is done with FumeFX. Now from the FumeFX rollout, under the rendering tab, there's an option to choose Arnold and Redshift volume, and you enable smoke, fuel and temperature for the rendering. The same thing is if you're using Redshift renderer. Now you need to assign for the Arnold, it's the standard volume material, and we're going to use smoke shading and using fire and temperature for the fire rendering with the black body emission. I would like to add some fog to this scene, and this is the fog material that we're going to assign to the Arnold scene atmosphere. And if I now move the time slider to frame 100, Arnold render view will update, and you see at this frame practically there is no fire emitted from the bed, and I'm going to unhide the sand plane that I have created before. So for rendering I use two samples for diffuse and specular, and volume indirect as well. And for the lighting this scene, I use the Arnold light set to the sky dome, and using a texture map, that's the physical sky, for physically based illumination. There is one more thing left to be done, is to add bed colony. So I'm going to create a new tab for this and new group. I change particle colors, and I'm going to use simple generator, and I'm going to create the beds within this box. So they are going to the colony group, just create on the first frame, speed 120 along the y-axis direction, and going to use location object, pick the box, and use the volume. I'll show you, I'll use the interdistance, but we'll get back to this a bit later, and set the position. So as you can see, those particles disappear. As we have load particle cache in load replace mode, we're going to use the import track so that it doesn't delete particles that we create from here. Okay, going to use the particle shape. I'm going to pick this flying bat and add the animation. Going to name it fly as well, from 1 to 21, and here I'm going to create one cache substep and master speed multiplier of 2, so they move their wings as fast as our main bat. And of course going to add a shape animation to start playing the fly animation. So this speed and the particle shape speed, those are two multiplied together, so you can increase or decrease the speed. Of course, gotta add that spin node to rotate particles along the z-axis, so the beds are facing into the same direction as our hero bat. I'm going to add some offset so they don't start flapping wings at exactly the same frame, but they're moving the wings at the same speed and they travel at the same velocity. So what I'm going to use is a random number generator. I'm going to use range, for example, between 0.8 and 1.2, and I'll use this as the shape animation speed multiplier, and I'm going to use this to set the speed as well. So I'm going to set speed to multiply speed. Okay, so now we have some bats flying faster, and those bats will be moving wings faster as well. Now, as you can see, I'll need to go back to the location object and enter distance, and let's say I don't want any particle within 16 units, so we don't have any beds that are going to overlap. Now we get nice random flapping, variation by velocity for those beds, and that's it. Thank you for watching this tutorial. I hope you learned something new. Like and subscribe. Thank you.